Welcome everyone. In this video, what we're going to do is we're going to learn how to name ionic compounds involving a transition metal. Okay? What happens is the transition metals, the majority of them have more than one oxidation number. So they're not going to follow those rules that we learned earlier. For instance, like how the alkali metals are always +1, the alkaline earth metals are always +2. Here, since they have more than one oxidation number, we're going to need to use a Roman numeral to indicate the oxidation number that's being used. The oxidation number would be the charge in this example. Now, the nonmetal is still going to end in IDE. The difference is that the transition metal will have a Roman numeral, like you see in the examples below. You could see here that iron plus the iron 3 here, Roman numeral 3, means that the charge is +3, and it'll always be positive because the metal is always positive, the nonmetal is negative. Chlorine is -1, it's a halogen, and if you crisscross these two, that's how you get FeCl3. Again, we don't have to write the 1 from the chlorine, and you see the answer there. Another one would be lead to iodide. Lead has here's the charge right here, it's +2. Iodide comes from iodine, which is a halogen, it's -1. And when you crisscross that, the lead gets the 1, which we don't write, and the iodine gets the 2, and there's the formula that you see there. So if you recall, the alkali metals are always +1. The alkaline earth metals are +2. Most of the members of the boron family are +3. These we usually skip. These guys usually do covalent. The nonmetals on the other side, the nitrogen family likes to gain 3. The chalcogens or oxygen family likes to gain 2. The halogens like to gain 1. And the noble gases are stable. Now, you'll notice that some of the metals on the bottom, especially these are two great examples, they also will do what most of these transition metals do over here. And these guys don't follow rules. They are going to use Roman numerals, which actually will make it easy for us because the Roman numeral is going to tell us their actual charge. We don't really need to look it up on the periodic table. And later on, you'll see I'll use lead and tin because they also have multiple oxidation numbers. They also have Roman numerals. So here's some of the more common ones. Again, this is not a complete list. This is just a few of them. I grouped them by charge, so you'll notice that copper can either be +1 or +2. So you'll see the Roman numeral there. Mercury is a really strange one. Notice that mercury, the mercury 1 actually is 2 mercuries together and it's +2. But yet it's called mercury 1 because if you think about it, there's 2 mercuries there. And each mercury has a +1 charge, but they're connected together, giving you this formula. That's where the 2 is down here. And although it says +2, that's the overall charge. Each individual mercury is +1, and then you got the normal mercury 2, which would be a +2 charge. The middle column has some of the more common ones. We looked at iron a little while ago. Iron can either be 2 or 3. Nickel can either be 2 or 3. Chromium also can be 2 or 3, and cobalt, and there are others. And here's lead and tin. You'll notice they're not they're what we call post-transition metals because they're after the transition metals. They're over here. So they are metals. They're below this zigzag line that we have here. And if you look, tin and lead can either be +2 or +4. Now this system of using Roman numerals is the stock name system. There is an older system called the classical system that uses Latin derivatives. We're not going to go over that system here. We're only going to go over the stock naming system, which utilizes these Roman numerals. Now, there are some exceptions. There are a couple of transition metals, not too many, that don't need a Roman numeral because they only have one charge. You see, the purpose of a Roman numeral is if you have more than one charge so that the person knows which charge to use. If you notice, zinc, silver, and cadmium, notice these are three exceptions. And we'll go back here to the periodic table. You'll notice that zinc over here and cadmium, they are actually always +2. So you will not have a Roman numeral. And silver is actually +1. So those three right there would never require a Roman numeral. All right. We could also combine a transition metal with a polyatomic. Here's a couple of examples. We have copper 2 hydroxide. So I'll show you how we got the answer. The 2 tells you to make copper +2. Hydroxide is a polyatomic that you need to remember. It's -1. The copper will get the 1, which we'll erase. We don't need to write the 1. But remember that there are 2 capital letters. We have to put that in parentheses, and we have to put the 2 outside. It is important that you put that parentheses because that 2 goes to both the O and the H. Then we got chromium 3 sulfate. So chromium is Cr, and the 3 tells you it's +3. Sulfate is a polyatomic. You can tell by the ending, the 8 ending. And when you crisscross this, the chromium gets the 2 from the sulfate, and then the 3 goes to the entire sulfate. So again, we got to put it in parentheses, and then we put the 3 out here. That's how you would do that one. Let's take a look at some more examples. So let's say we had iron, Roman numeral 2, bromide. Now, when you see this, that's usually a nonmetal. That's Br, the nonmetal bromine. And it's a halogen, it's -1. Iron is Fe, and it tells you the charge right there. So you set it up. Metal's always written first. Crisscross, the Fe gets the 1, which I'm not going to write. The Br will get the 2. Drop the signs. And there is iron 2 bromide. Let's look at another example. Let's say we have tin, Roman numeral 2, oxide. So tin is Sn. Oxide comes from oxygen. It's an element. Oxygen has a -2 charge from the periodic table, and tin has a +2 charge. Remember that when the charges are the same, they're going to end up canceling out or being reduced. And you got a 1-to-1 ratio of tin to oxygen. Now, let's take a look at this. Let's say we had lead, Roman numeral 4, and let's put here chromate. Now, look at this one. Pay close attention to this. Lead is Pb. We have the charge, +4. Chromate, you could tell that's a polyatomic. So from our list, chromate is Cr04 -2. Now, look at these numbers. Notice that when we crisscross, you get a 2 here, and this 4 is this one here, but the 1 over here goes outside. But notice that a 2 and a 4 is divisible by 2. We still need to reduce this. This will become a 1. This will get reduced to a 2. So you must reduce it to lowest terms, and you're going to end up getting this as your final answer after you reduce. So make sure you remember to do that. Let's try another one here. Let's look at nickel, Roman numeral 3, hydroxide. Let's look at that right now as an example. So nickel is Ni. This tells you the charge. Hydroxide is a polyatomic. Even though it ends in "ide," you got to remember it's a polyatomic. So the nickel will get the 1, which I'm not going to bother writing. And remember what we said earlier. there's two capital letters there, so you must put it in parentheses and put the 3 out here. You got to remember to do that. All right, let's take a look at another example. So look at this one here, zinc acetate. Now, zinc is one of the few polyatomics that does not have a Roman numeral. You're going to have to remember that zinc is always +2. It does not require a Roman numeral even though it's a transition metal because it only has a one single charge and it's +2. Now, acetate is the polyatomic C2H3O2 with a -1 charge. So when you crisscross this, the zinc gets the 1 here, which I'm not going to bother writing, but the acetate, the entire thing, is going to get this 2. We need to put it in parentheses and then put the 2 out here. Okay, so you got to remember to do that. All right, let's try one more. Let's try silver nitrate. This chemical can stain your hands. And silver is Ag. It is also one of those elements, transition metals, that does not have a Roman numeral. Silver is always going to be +1. So it will not have a Roman numeral because it always has that charge. Nitrate is NO3 with a -1 charge. These two are going to cancel, and you're going to be left with AgNO3. Okay? Now, what we're going to do is we're going to go backwards. I'm going to give you a formula, and we're going to name it. Okay? So here's a regular one. Let's say I had, let's see here, Mg, and let's put here MgCO3. When we name this, the metal is magnesium. Magnesium is not a transition metal, so it does not need a Roman numeral. It's always +2, so don't put a Roman numeral. And this, if you recognize it, it's carbonate, so it's magnesium carbonate. Now, sometimes you might have to put a Roman numeral. I'm going to give you an example. So let's say you had FeCl3. Iron is a transition metal, which means unless it's zinc, cadmium, and silver, transition metals will require a Roman numeral. Now, how do you figure it out when you're going backwards? Very simple. I want you to uncrisscross this. Think about it. That 3, if you uncrisscross it, that 3 came from the iron. Okay, if you re-crisscross this, you get this. That 3 came from the iron. So the iron that you were using was the +3, so you're going to use a Roman numeral 3. And then remember the nonmetals chlorine, change it to chloride. So it'll be iron 3 chloride. We'll do a couple more like that, okay? Here's the next one. So let's say we had, let's say SN NO3 4. Now, tin is a post-transition metal. It does have a Roman numeral. In fact, tin can either be +2 or +4. And you could tell with this one, when you uncrisscross it, that the 4 came from the tin. So tin, in this example, is the +4. Okay? So, actually, I wrote that wrong. So what you do here is you put a Roman numeral 4 in parentheses, and then this is nitrate, the polyatomic ion. So you name that as is, and there you have the answer. Okay? Now, I'm going to give you one a little bit more challenging. Look at this one. We know that's copper. Now, copper is a transition metal. It does require a Roman numeral. Earlier, I told you that copper is +1 or +2. The question is, which one is it? So I always use this. Let's play a little detective. The non-metal will always tell you what the metal is doing. You see, the non-metal oxygen is always -2. So the question is, what is the metal? Is it +1 or is it +2? Now think about it. Notice that in the formula you don't see any 2's. That's because the only way to get rid of a -2 is if the other one is a +2, so they cancel. When you crisscross copper with a +2, the 2's will cancel, giving you this formula over here. So the copper that we used here was actually the 2 form, and this will be called copper 2 oxide because the oxygen gets converted to oxide. Had it been copper 1 oxide, the formula would have been different. It would have been this. We would have crisscrossed, and you would have gotten that as an answer. That would have been copper 1 oxide. But the one we had was copper 2 oxide. Let's try another one. So let's say you had PbSO4. Okay? So here, if you recall, lead is one of those post-transition metals. Lead can either be +2 or +4. Okay? Again, if you want to find out which lead we're using, the trick is to figure out what the sulfate charge is. Sulfate's always going to be -2. So here are your two choices. +2 or +4. When you crisscross these two, the 2's will cancel and you will get PbSO4, which is the one we have here. So the lead that we used to create that compound is the 2. So it's going to be called lead 2 sulfate. Had we used the 4, crisscrossing it would have given you the 2 would go to the lead. The sulfate would have gotten the 4. We would have had to have reduced. Remember that. And it would have looked like this. It would have looked like PbSO4 with a 2 down here. Okay? And that's not what we had. So this lead was lead +2. So we had to put the Roman numeral. Okay? Now, if you had something like this, this is zinc. And yes, zinc is a transition metal, but zinc is one of the 3 transition metals that don't have a Roman numeral. Silver, zinc, cadmium, they don't have a Roman numeral. So don't put a Roman numeral, okay? Put zinc, and this is the polyatomic carbonate. So this is just simply zinc carbonate. Do not put that Roman numeral. It's not needed. Okay, so the answer is zinc carbonate. Okay, let's try another one here. How about CrMnO43? So first, the minute you realize that Cr is a transition metal and it's not silver, tin, or cadmium, you know it needs a Roman numeral. So this is chromium. Okay? Now, this is permanganate, the polyatomic ion. He's always -1. With this example, you can simply uncrisscross it. That 3 came from chromium. So the chromium being used is the +3. And then the name of that polyatomic is permanganate. And that would be the answer to this one. Okay? And we'll finish up with one more here. So let's say we had, let's see, FePO4. Okay? Now, iron is a transition metal, so it's going to need a Roman numeral. Now, the question is, what iron are we using? Well, iron, if you recall, can either be either 2 or 3. Notice that there is neither a 2 nor a 3 here. So let's see what's going on. Remember the trick. Find out what this guy's doing. He's always -3. If you find out what he's doing, it will reveal what the other one is doing, which is the iron in this case. So if you think about it, the reason that there's no 3's in the formula is because iron has to be a +3 so that it will cancel the -3 of the phosphate. So the iron that we're using to create this formula would be iron 3 and PO4 is phosphate. Had it been the other iron, which is the +2 iron, and we crisscross that, you would get Fe, the 3 would go here, the 2 would go to the entire phosphate, so you would put it in parentheses, and that one would have been called iron Roman numeral 2, because we used the 2 phosphate. Okay? So that's how you name when there are polyatomic ions involved. Okay?